So, hello everyone. Let's talk about today's GeeksforGeeks problem of the day. The problem is the majority element, and this is the very simple and easy to understand problem. The problem statement given as you have to find the majority element in the array. What is the majority element? If it is not exist, return -1. What is the majority element? An element which occurs more than array dot size by 2. Okay. So this is the simplest problem statement which you have given. So let's see on one note. I will solve this problem. Well, let's see with a small example like 1 1 2 3 4 and 1 1. Okay, so this is the array size is a 7, so I'll just keep n as an array size. N is equal to 7 and n by 2 is equal to 3. Okay, now I'll calculate the frequency of each element, which is 1 occur 4 time in array, 2 occurs 1 time in array, 3 occurs 1 time in array, and 4 occurs 1 time in array. What I'll do, I will pick maximum frequency among all these elements. So the maximum frequency is a 4. I will check the 4 is greater than 3. Yes, it is greater than 3. So which elements occur 4 times? It is a 1. So the answer is a 1 in this case. So if you look, if you clearly look this example test case, so answer is a 1 for this example. Okay, now if I have something like this 1 2 3, then 1 will occur one time, 2 will occur one time, and 3 will occur one time. What is the 3 by 2, which is 1? So what is the majority element in here? It is a 1. So 1 is greater than 1. No, it's not. So for this test case, the answer is a -1. Okay, so this is the problem statement is saying you have to find the maximum frequency among all the element, and you have to check either it will be more than n by 2, which is the array dot size by 2. If it is, then return the that element, or if it is not, then return the -1. So for solving this problem, you have to multiple approach. You can use a nested loops, you can use a map, you can sort the array and calculate the frequencies. So all these approaches are good, but we have given some constraint and expected time complexity. The expected time complexity of big of n and the space complexity of big of 1. So without using extra space, you have to solve this problem in a linear time. So there is one greedy algorithm which is more sorting algorithm. So this algorithm focus on the one point, which is the majority element is always occurs more than n by 2. Okay, this m is stand for the majority element, the frequency of the majority element. So majority elements always occurs more than n by 2. So no matter what is the other element, if you cancel out this element with the other, it will still remain, its frequency still remain. Now we can't directly calculate the frequency with, we calculate the frequency indirectly, but still it will work. Now let's see how it will work. Now I'm going with the simplest example. So here is a 1 1 2 3 4 and again 1 and 1. Okay, so if I am observing this problem, this is, so answer is a 1, we already discussed here, but we will solve this using the more sorting algorithm. Now what is more sorting algorithm say? Pick the one key. Okay, so I'll just pick the key as a 1. Okay, and the count of the key, which is also the 1. Okay, now what I will do, I will try to cancel out this 1. Either I will increment it or either I will decrement it. If it is matching, I will increment it. It will not match, I will decrement. And if it will become a 0, I will change the key. Okay, so let's see. I'll start from here to here. So my I is greater than or equal to n. Okay, so let's check. 1 is equal to key. Yeah, it is. So the count will become a 2. Then 2 is equal to key. No, it's not. Then I'll remove the key count by 1. So decrease the count by 1. So it will become a 1. Now 3, the key is not equal to, so it will become a 0. Okay, now as it is becoming a 0, I can say there are, if it is becoming a 0, so what I'm saying, there are some element which is cancelling out the my key, the frequency. So there are some element which is cancel out the my key. Now So what is the problem in this? If it get cancelled out, so there is no chances ki 1 is the majority element. Why there is no chances to 1 is the majority element? Let's pick this element. Okay, this array, this size of the array. Okay, the size of the array is a 4. If majority element, you have to tell there is exists majority element in the size 4. What you will say, the frequency of that element is greater than 2. Why 2? Because 4 by 2 is a 2. Okay, and what is the definition of the majority element? It is strictly more than n by 2. So the frequency of the element is greater than 2. If this exists, then majority element. If it is not exist, then there is no majority element in that array. Okay, so till here what I'm doing, I'm cancel out the element with the other element. If it is not matching, I'm cancelling out. So one getting cancelled out, so there is no more frequency of one exists in that array. So one is not the majority element. So there might be a chances 3 will be the majority element, because there is a chances, if I'll see if there is a 3 x time, so there might be a chances 3 will be the majority element. But one, I'm sure one is not a majority element. So I will update the key. So key will become a 3, and the frequency of the 3, the frequency of keys, the count of the key is a 1. Okay, key occur one time in the array. Now I'll check here to here. So next time I'm go here, the 3 is not equal to 4. So making 0. 4 will be the updated key, and the 4 frequency is a 1. Why 4 is the key? Because 3 is not a majority element, because I'm cancel out the 3 with the 4. Okay, but there might be a chances 4 will be the majority element. Okay, I'm going to the next, and next is a 1. So it will get a cancel out because 4 is not equal to 1. So key will be the updated to 1, and the frequency of 1 is 1. Now I'm going here, the 1 will become a 2. So frequency of 2. Now the element which is left in a key, I'll just check it out. Either it will be the majority element or not. So I will check frequency of 1 with the in the array. So 1 frequency is a 4. Okay, and I'll just check 4 is greater than 3. Yes it is. So answer is a 1. Okay, for this example. Now why this is working, just consider you have an array element a1, a2, a3 till an, and the n is equal to 10. So if there is exist majority element, then it is always greater than 5. Okay, so I'm considering the a1 is a majority element, and a1 frequency is a 6. Then a2, a3, a4. Okay, this is for unique element, and his frequency is a 4. Combining all these elements, the frequency is a 4. So if I'm cancelating each element with, if I'm cancelating this element with each others, I always left with the frequency 4, 2 of a1, because a1 is a majority element. Even I'm cancelling each others, still I left with the last element which frequency is more than all of this element. Okay, and I'll check, because in some example there might be a chances the frequencies are coming equals. Like I'll just say, I'm just giving one example, like 1, 1, 2, 2, and 3. Okay, so I'll add 3 here, and I will add 1 here. Okay, no, let's see, the key is equal to 1 and count is equal to 1. Okay, key will be updated to 3, the count will be 1. Okay, key will update it to 2, the count will be the 1. The key will not update, the count will update it to 2. Okay, key will update it to, key will 2, the count will be 1. Okay, and here the key will be the count will be the 0, key will be updated to 1, and the count will be the 1. Okay, so all the elements are same. So for this I get a 1. So I'll just check out what is the frequency of 1. The frequency of 1 is a 2. So while I'm checking the again cross check, because there might be chances key you will have this equal frequency or any other case. So on a second pass, I'm checking the frequency of 1 again to make sure that element occur more than n by 2. So the frequency of 1 is a 2, and 2 is not greater than what is this element 3. Okay, so for this example return -1. Okay, let's code it. So first I'll take one integer. First I'll take the one integer key is equal to 0 and the count is equal to 1. Okay, and key is equal to array of 0. Okay, now I'll go from I is equal to 1 to I is array dot size and I plus plus. In this I'm checking key is equal to array of I, then I will increase the count, else I will decrease the count. If count will become a 0, then I will update the key to array of I and count is equal to 1. Okay, now on the second pass I will make count is equal to 0. Then for auto I'm using for each loop for a clean code. Okay, now if I is equal to key, increase the count and check once return count is greater than key size by 2 array dot size by 2. If this condition satisfy, return the key. If it's not, then return the -1. It's similar to the if else, like if count is greater than array dot size, return key, else return -1. Similar to this, but this is very lengthy, so I'm using this. It is a ternary operator. So let's check it is passing all the test cases. Okay, it passed the example test case. I reset, let's see. Okay, submit it. Let's submit it. Indeed, it passed all the test cases. So this is for today. Let's meet tomorrow. Goodbye for now.